Now I am become death, the destroyer of worlds.
A brilliant mind emerges. Oppenheimer's early years. Julius Robert Oppenheimer, born in 1904, was a child of privilege and intellect. He excelled in his studies, quickly mastering languages, literature, and science. Oppenheimer's brilliance was evident from a young age. He possessed a thirst for knowledge that extended beyond the classroom. This intellectual curiosity would shape his destiny and alter the course of history. Oppenheimer pursued physics at Harvard and Cambridge. He dove deep into the world of theoretical physics. His work explored the mysteries of quantum mechanics, a revolutionary field at the time. His passion for understanding the universe at its smallest scales laid the foundation for his future endeavors. Oppenheimer's journey took him to Europe, where he collaborated with leading scientists. He immersed himself in the world of cutting-edge research. This period of intense study and collaboration honed his skills and solidified his place as a rising star in the world of physics. The world, however, was on the brink of war, and Oppenheimer's expertise would soon be called upon for a project of unimaginable consequence. A world at war, engulfed in chaos and uncertainty. The genesis of the Manhattan Project, a pivotal moment in history. The year 1939 marked the beginning of World War II, casting a dark cloud over the globe. Nations were drawn into a conflict that would reshape the world. The spectre of Nazi Germany, armed with advanced technology and a relentless ambition for domination, posed a grave threat to the Allied nations. In the United States, scientists, many of them refugees from Europe, grew increasingly alarmed by rumors of a German atomic bomb project. These scientists, having fled the tyranny of the Nazis, were acutely aware of the dangers posed by such a weapon. The thought of such destructive power in the hands of a tyrannical regime was terrifying. The potential for unprecedented devastation loomed large. Driven by a combination of fear and patriotism, these scientists urged the US government to develop its own atomic weapon. They knew that the balance of power could shift dramatically if the Nazis succeeded first. They understood the potential consequences of such a weapon, but believed that the risks of inaction were far greater. The stakes were incredibly high, and the future of the free world hung in the balance. In 1942, their pleas were answered with the formation of the Manhattan Project, a top-secret research and development program unlike any other. This initiative would become one of the most significant scientific endeavors in history. The Manhattan Project, shrouded in secrecy, brought together the brightest minds in physics, engineering, and chemistry. These individuals were tasked with an almost unimaginable challenge. They hailed from across the United States and around the world, united by a common goal: to harness the power of the atom before it could be used for unimaginable destruction. Their diverse backgrounds and expertise were crucial to the project's success. The project's success would depend on their collective brilliance, unwavering dedication, and ability to keep their work hidden from prying eyes. The secrecy was paramount, as any leak could spell disaster. These scientists worked tirelessly, often late into the night, driven by the urgency of their mission. The weight of the world was on their shoulders, and failure was not an option. The culmination of their efforts would change the course of history, ushering in a new era of scientific achievement and ethical dilemmas. The Manhattan Project was not just a scientific endeavor, it was a race against time, a battle for the future of humanity. Unlocking the atom. The science behind the bomb. The journey to harness the atom's power was a monumental scientific endeavor that changed the course of history. At the heart of the Manhattan Project lay a scientific challenge of unprecedented complexity: how to build an atomic bomb. This project brought together some of the greatest minds of the 20th century, all working towards a common goal. The key to this destructive power lay in the atom's core, the nucleus, which contains vast amounts of energy. Understanding the structure of the atom was crucial to unlocking its potential. Scientists had discovered that splitting the atom, a process known as nuclear fission, could release this energy in a powerful explosion. This discovery was a turning point in nuclear physics. The element uranium held the key to unlocking this power. It was abundant and had the right properties to sustain a nuclear reaction. Certain isotopes of uranium, particularly uranium-235, were highly fissile, meaning their atoms could be easily split. This made uranium-235 the ideal candidate for the bomb. When a neutron struck a uranium-235 nucleus, it caused the atom to split, releasing energy and more neutrons. This process was the foundation of the bomb's explosive power. These neutrons, in turn, could strike other uranium-235 atoms, creating a chain reaction. This chain reaction was self-sustaining and released enormous amounts of energy. The challenge for the scientists of the Manhattan Project was twofold. First, they needed to find a way to enrich uranium, increasing the concentration of uranium-235 to a level high enough to sustain a chain reaction. This process was complex and required innovative techniques. Second, they had to design a device that could initiate and control this chain reaction, unleashing its destructive power at the intended moment. This required precise engineering and a deep understanding of nuclear physics. The fate of the world hung in the balance as these brilliant minds raced against time to unlock the secrets of the atom. Their work not only changed the outcome of World War II, but also ushered in the nuclear age, forever altering the course of human history. Section 4. Los Alamos, the secret city. Section 5. Trinity, the dawn of a new age. After years of relentless work and countless challenges overcome, the moment of truth arrived. On July 16, 1945, the first atomic bomb, nicknamed Gadget, was detonated in the New Mexico desert at a site codenamed Trinity. The test marked a pivotal moment in human history, ushering in the atomic age and forever altering the course of warfare. The explosion was unlike anything ever witnessed before. A blinding flash of light illuminated the pre-dawn sky, followed by a deafening roar that shook the ground for miles around. A massive fireball, hotter than the surface of the sun, rose into the air, leaving behind a mushroom cloud that soared miles into the atmosphere. The scientists and military observers present at the Trinity test watched in awe and trepidation as the awesome power of the atomic bomb was unleashed. The sheer destructive force of the blast left no doubt that they had created a weapon of unprecedented power, a weapon capable of ending the war but also of unleashing unimaginable destruction upon the world. Section 6. Hiroshima and Nagasaki, the bomb's devastating power. The events that unfolded in these two cities would forever change the course of history and the nature of warfare. With the Trinity test a success, the decision was made to use the atomic bomb against Japan, which had so far refused to surrender unconditionally. This decision was not taken lightly, as it involved the use of a weapon of unprecedented destructive power. On August 6, 1945, an American B-29 bomber, the Enola Gay, dropped an atomic bomb nicknamed Little Boy on the city of Hiroshima. This marked the first time in history that a nuclear weapon was used in warfare. The bomb detonated above the city center, instantly killing tens of thousands of people and leveling a vast area. The sheer force of the explosion obliterated buildings, infrastructure, and lives in an instant. 3 days later, on August 9th, a second atomic bomb, Fat Man, was dropped on the city of Nagasaki. This second bombing compounded the devastation and further demonstrated the terrifying power of nuclear weapons. The devastation in both cities was unimaginable. Entire neighborhoods were reduced to ashes, and the landscape was transformed into a scene of utter desolation. Buildings were reduced to rubble, fires raged uncontrolled, and the air was filled with the stench of death and burning. The survivors faced a nightmarish reality, with many suffering from severe burns and injuries. The bomb's effects extended far beyond the initial blast, with radiation sickness claiming countless more lives in the weeks, months, and years that followed. The long-term health consequences were severe, with many survivors, known as hibakusha, enduring chronic illnesses and suffering. The bombings of Hiroshima and Nagasaki brought a swift end to World War II, but at a terrible cost. The world witnessed the horrifying potential of nuclear weapons, and the ethical implications of their use became a subject of intense debate. The use of atomic weapons on civilian populations sparked a fierce debate about the morality of such weapons and the long-term consequences of their use. Many questioned whether the ends justified the means and whether humanity could ever justify such destruction. The world had entered the atomic age, forever marked by the shadow of nuclear annihilation. The bombings of Hiroshima and Nagasaki served as a grim reminder of the devastating power of nuclear weapons and the need for global efforts to prevent their future use.